scatter diagram, also known as a scatter plot. So in some cases, a scatter diagram is also known as a scatter plot. Now, this is used mostly when someone is conducting an experiment, right? And someone wants to see the relationship between two variables. So let's just call those variables maybe A and B, right? So there are two variables, and someone is investigating whether there's a relationship between those two variables, right? If I change one thing, will the other thing change? So typically, you will have a graph, right, with two axes. On one axis, you have one variable A. On the other axis, you have another variable B. And then what happens as the experiment is conducted, the person plots some points or some readings that they get from their experiment. When they plot those points, right, those points are sort of scattered. So it's called the scatter diagram, right? And then they try to get information from those points about the relationship between A and B. Now, the information or the relationship that happens between the two variables is what we call correlation, right? So there are generally three types of correlation that we'll take note of. So the first thing is if there is a downward trend, right, as y increases, seems as if x is decreasing here. So if there's a downward trend, we say there is negative correlation between the two variables, x and y, whatever they may be. And then if there's an upward trend, right, as y increases, x is also increasing, we say there's positive correlation, right? It seems from the information we're collecting that if you increase one variable, the other variable also increases. Now, if there's points scattered in a really haphazard fashion that you can't deduce any form of trend, it means there's zero correlation, right? Or no correlation. It means there's no relationship between x and y. The changes in x are independent of the changes in y and vice versa. Now, let's have an example here. A student conducts an experiment to understand the effect of temperature on the germination of seeds. She planted 8 bean seeds and put them in environments with different temperatures. So after 2 days, she recorded the following. So here are temperatures, right? For the bean seed at 0 degrees Celsius, it grew 3 millimeters. At 5 degrees Celsius, 8. At 10, 6 millimeters. At 15 degrees Celsius, 14 millimeters. At 20 degrees Celsius, 20 millimeters. At 25 degrees Celsius, 22. At 30, 28. At 35, 30. At 40, and 21. So these are the two variables we're looking at in this case, right? This is our temperature, which is a variable on one axis, and then a length of seedling is going to be variable on another axis. So here, our student has already plotted the points, right? Remember, at 0 we have 3, so our student plotted at 0, put 3 there. And then at 5 there's 8, so our student went to 5 and plot an 8. At 10 there's 6, our student went to 10 and plotted 6, so and so on and so forth. So these plotted points represent what's in this table here. So the first thing is draw a line of best fit. So when you're drawing a line of best fit, you understand that not all these points will fall on that line, right? You're just going to try and draw a point that goes through a lot of lines, right? In fact, it goes through most of the lines and is most effective when representing the information there. So the one I would draw would probably be like this. Remember, you use your ruler here. So this is a straight line, you use your ruler. So that's my line of best fit. So as you can see, not all points fell on the line. You've got that point, you've got that point, you've got that point, you've got that point. You've got about 4 anomalies, but you've got about most of the points falling on the line. So that line is what we call the line of best fit. The next thing is what type of correlation is shown here. Now, as you can see, there's an upward trend, right? We've identified the trend here, and there's an upward trend. So when there's an upward trend, we say there's positive correlation. There's positive correlation. It seems as if you increase the temperature, the seedlings will grow more, right? An increase in temperature seems to be encouraging growth in the seedlings. And the last thing is, what length would you expect for a seedling that germinated at 18 degrees, right? So 18 degrees is temperature. So we're going to go to the temperature axis and identify where 18 degrees will be. So 18 degrees, let me just use another color, would be somewhere here. I presume that's where we can expect 18 degrees Celsius. So what we need to do is, with your ruler, you just need to plot your way upwards straight until you come in contact with the line. And then when you've done that, you go across to the vertical axis. So at 18 degrees Celsius, it seems as if we've got about an 18 millimeter length. So that's the length that you expect. You expect the seedling to grow to 18 millimeters. And this information, you're now using your line of best fit, which you plotted in the first place, to get that information. So what did we do? We drew our line of best fit, and having drawn our line of best fit, we were able to name the relationship we're seeing, and finally we were able to use our line of best fit to make certain predictions using the given relationship between the two variables.